This is an explanation of how to set up page 179, problem number 82. Now I have simplified the drawing that we have from the book here. You'll notice that I'm labeling L as the crease, and the dotted segments that I have here are the folded paper over the original. We were told that the width was 20 centimeters. So we can start labeling some pieces here. We know that this dimension here from the fold to the corner has to be L times the sine of theta, the angle there in the corner. We also know that this has to be L sine of theta. I'm sorry, L cosine of theta. Now a couple of things I want to pencil in here. Since we know these two angles, we know that this angle would be 90 minus that angle. We also know that this angle, because of the right angle that would be sticking up here, would also be 90 minus theta. Because of these two needing to add to 180 with this third angle over here, we know that this angle is 2 theta. That's a key part to setting up our equation. Now, we also know that this dimension here, dotted, would have to be the same as its part that it was folded from, which would be L sine of theta. So when we look at the small triangle that's formed over here, you'll notice that we need to find this dimension. And what we want to try to do is to add the two of them together to give us 20. So we can set up a trig function here using cosine of our 2 theta equal to the adjacent, which would be x in this case, over the hypotenuse, which is L sine of theta. Remember, this is the hypotenuse for this smaller triangle over here on the left. Now if we solve that for x, you'll see that we get x equals L sine of theta cosine of 2 theta. Now we have that second dimension that we need in the width to add them together to give us 20. So now we know that L sine of theta plus the expression we found for x, remember that was L sine of theta cosine of 2 theta, we know that that equals 20. Now you can proceed through the problem to try to minimize the length of that crease.